So, students, as in the previous class, we were discussing about the measurement of length, devices of measurement, and what precaution, what things we have to keep in mind when we measure the length. Correct. Now we will see about the motion, moving things around us. That is our topic, moving things around us. So, as in the class first only from this chapter, I explain you when object can be said it is in motion, when it moves or it changes its position with respect to its surrounding, we can say it is in motion. Now let's some more example about it. So this is one ant. Okay, we can mark some point in which direction ant is moving, and we can mark point. Suppose this is one point I have marked. Now we can see the distance of ant from this position. It is here, this position. Now it is moving. Now we can see the position and distance of the ant from this point. This point name we can give O. Then one more point we can mark, and one more position of the ant from the point O. So what we are saying, finding, what we are able to conclude, continuously the position of ant is changing with respect to object O. Correct or not? So we can say this ant is moving. Okay. Now the object which are not moving, what about them? Suppose if a tree, if you see one tree, a roadside, suppose this is the road. Okay. This is the road. Here are some trees. So, if yesterday also you saw this tree was here only, today and last year also this tree was on the same place, so will you say it is in motion? No, because its position is not changing with respect to road, so we can say it is not in motion, it is in rest. In your school bag, your books are there, pen, pencil, stationery. If you see, they will be still, their position is not changing, then we can say they are in rest. So in short, when objects are in not motion, then they are said to be in rest. Now we will see different kind of motion. Have you seen the position of the train? Suppose whenever you are in the railway platform, or you are at the railway platform, correct? Suppose you are at the railway platform, where you are, railway platform. Okay, platform means the place where trains stop. That is called railway platform. Everybody knows about it, isn't it? Platform. Now here train is passing this place. Let me draw the train. Like, wait a minute. I'll draw a nice train for you. So suppose this is the train. Correct. This, and you are standing here. Now train is moving. Its position is changing. So we can say this train is moving because position is changing, and its each and every part position is changing with respect to track or with respect to platform. Even its wheels are moving. It's a coaches. These coaches also moving with respect to the railway platform. So means along with the train, its parts also moving. This kind of motion is a straight line motion. Rectilinear motion. What we call this kind of motion? Rectilinear motion. Or we can say when any object move in a straight line. When any object moves in a straight line, then we can say rectilinear motion, because some students in your on your Republic Day, Independence Day, they do march past. In the march past, they have to go straight line. That kind of motion is called rectilinear motion. Which motion? Rectilinear. One second. Wait a minute. This motion is called rectilinear motion in straight line. Now, if a ball, if there is a ball, this ball is rotating and revolving. Suppose it's changing the position, it's rotating also, and suppose there is a ball which is rotating. So you can see here the march past. The army people are doing march past, and then car, buses, they are moving in a straight line. So these are the example of which motion? Linear, rectilinear motion. Now, what about the motion of this bullock? It is a one axle. On that, this bullock is revolving like this. It is going in a straight line. Okay, so this kind of motion, what we call? This kind of motion is called revolutionary motion. Revolutionary motion or revolving. ठीक है? What is happening? This bullock is revolving around this place. So revolving motion, revolutionary motion also it is called. Okay. Now you can see the fan. In the fan, what is happening in the fan? If you see the fan blade, suppose you mark some point, or you mark in the blade of a fan, and you see its parts position is changing with respect to this axle, or this with respect to this rod. No, its position will not change. How much fan rotates, but the blade position with respect to rod will not change. So this kind of motion, when the part of object as it's a fixed position, this motion is called rotatory motion. What do we call this kind of motion? Rotatory motion. Now some motion you can see, this boy is pushing her sister on the swing. So in swing, what happens? It comes back, comes front, then goes back, front, back. So to and fro, this kind of motion, to and fro motion, front, back, front, back. So this kind of motion, when objects move to and fro, front, back, these kind of motion are called which motion? Oscillatory motion. Which motion? Oscillatory motion. Correct? Oscillatory motion. You can see some more example of oscillatory motion. The park, when you play on the seesaw. So in the seesaw, what happened? This kind of one device, here one girl or boy sit, here one more boy or girl sit. They goes up, down, up, down. This kind of motion is also to and fro motion. This kind of motion, when any object moves up, down, or front, back, they move to and fro, this kind of motions are called oscillatory motions. Okay, and any object or any person, have you seen this is circular ground, running track, and here the athlete is running around the circular track. So continuously position is changing, and he is moving around the circular path. He is moving around the circular. The athlete is moving around the circular track, circular path. This kind of motion, whenever object move around a circular path, circular orbit, is called circular motion. Correct? So different type of motion we have covered today's class. Tomorrow we'll come with another topic. Till then, thank you. Take care. Have a nice day.